All right, we're supposed to have our exam on stoichiometry next class, and some people were absent, so I thought I would go over a couple practice problems. These are the ones you're going to have on your test. All right, so the molar mass of NaCl, which is sodium chloride, which is salt, is 58.44 grams per mole. I don't know if you remember, but remember, all you got to do is look at a periodic table. So you find sodium over here. Its average atomic mass is 22.99. And then chlorine over here is 35.453. If you add those two numbers together, you get 58.44. So that's how you find the molar mass of a compound. All right, so I'm going to do this one for you. So there'll be two of these on our exam, two of them. So this is just, we're going grams to moles, simple grams to moles. So what I told you last time, we're going to take this number, whatever is given to us, we're going to put that on the top left. So line times line. And we got 2 moles of NaCl. So I'm going to put 2 moles NaCl. All right. So since we got moles on the top, we want grams. So we want to get rid of moles. So 1 mole will go on the bottom. 1 mole. And what does 1 mole of sodium chloride weigh? It's 58.44 grams. So 58.44 equals. All right. Let me grab my calculator if I can find it. All right. So remember, it's just the top times the top divided by the bottom. So this is a 2. Didn't write the best 2 ever. So it's 2 times 58.44 divided by 1. All right, so let me get my calculator going. And so it's basically just 2 times 58.44. 58.44 times 2 equals, so 2 moles of sodium chloride weighs 116.88 grams. All right, so there'll be one like that. That's a moles to grams. I'll do another one. All right, so the last one was it was moles to grams. It gave us moles. It wants grams. This is the opposite. You'll have one of these on the test. Maybe it's not exactly the same. It may not be water H2O. It may not be 36 grams, but it will be a grams to moles conversion. All right, so the molar mass of water H2O is 18 grams per mole. Let me get my drawing tool. All right, so once again, we always start out the same. Let's see if we can get it to move. Go to the left. There we go. All right, so we're going to start out with line, big line. I'm going to go big line so I can fit it on there. Times line. What is it the problem giving us? It's giving us this, 36 grams of H2O. So that always goes top left. 36 grams of H2O. Now, since it's grams up here on the top left, grams is going to go bottom right. So we're going to get rid of grams, and we're going to turn it into moles. So 1 mole won't go on the bottom this time. It's going to go on the top. And what is 1 mole? What's the mass of 1 mole in grams? It's 18 grams per mole. So 18 will go on the bottom. So it's just 36 times 1 divided by 18. And if you do that with your calculator, 36 times 1, of course, is 36. 36 divided by 18, I believe, without using my calculator, is 2. So 36 grams of H2O would be 2 moles. All right, so on the exam on Friday, if it's this Friday, which I'm pretty sure it is, we'll have 2 of those just like that. I mean, I'm going to do a couple more of some different types of questions. All right, so now another type of question we're going to have. I'm going to post this on Google Classroom for those of you, most of you guys were in class and you got it on paper, but I'll post the digital version for some of you guys that weren't there today. All right, so there will be, I want to say 3 to 4 mole to mole conversions. So I'm going to go down to let's go number 3. So step 1 on these things, you're going to have to balance the equations. Let's see if step 1, I can get my little pen to work, go on drawing, see if it'll move my cursor, and it will. All right, so you can see this is not balanced. We have H2, 2 hydrogens on the left. We have H3, 3 hydrogens on the right. We have 2 nitrogens on the left. We only have 1 on the right. So I'm going to balance it way over here. Whenever you have the numbers 3 and 2, the common number is 6. So we're going to turn these H's into 6. So I'm going to balance the hydrogens first. So I'm going to do that by going NH3. And in front of it, to make 6 H's, I'm going to put a 2. Because 2 times 3 will give us 6 hydrogens. Now I'll draw the arrow. And then we got H2. So we got 6 hydrogens over here because 2 times 3 is 6 hydrogens. Over here we only have 2. So we need 6 to make it equal. So I'm going to put a 3 in front of the H2. So now 3 times 2, now we have 6 hydrogens. Now let's see. We have 2 N's. So we have 2 nitrogens. Oh, we have 2 nitrogens N2, that means 2 nitrogens. Boom, now we're totally balanced. All right, so let me clear my throat before I finish this problem. All right, so I got my throat kind of clear, got a little bit of a cold or some allergies. But anyways, come on, there we go. All right, so now that we got our balanced equation, so this gives us the mole ratio. So remember, there's no 1 here in front of the N2, but there really is. 1 mole of nitrogen gas will react with 3 moles of hydrogen gas, H2, to make 2 moles of ammonia, NH3. All right, so we go line times line. And remember what it gives us. Here's what it's giving us. Now, we don't need to know grams here because this is mole to mole, so we're not putting it into grams. So we got 3 moles of N2. So 3 moles of nitrogen gas, N2. So now we want to know how many moles of ammonia, NH3, can be made. So N2 is going to go on the bottom. N2, because if it's top left, it will go bottom right. And we're going to cancel out the N2s. And what we want will go on the top. We want NH3. Now, what's really important about these is not their letters, it's the numbers that go in front of them. So I'm going to put a 1 here because there really is 1 mole of N2, even though you don't write a 1. Because obviously, if it isn't 0, because if there were 0 moles of N2, why would we write N2? So there's a 1. So next to the N2, I'm going to put its 1 next to it because that's what's really important. And the NH3, it has a 2 next to it. So I'm going to put a 2. All right, so now we got it all set up. Now it's just equals top times the top divided by the bottom. 3 times 2 is 6. 6 divided by 1 is still 6. So we will make 6 moles of NH3. There's 1. I'll do 1 more. All right, so I'm going to do number 7. I like it because it's already balanced. And I believe some on your exam will already be balanced. Some will not be balanced. So some of them are going to have to be balanced. This one I balance because it's hard. Look at the coefficients: 2, 6, 2, and 3. You know, you would have taken longer to balance this thing than you do to solve the problem. All right, so moles to moles, H2, 4.5 moles of Al. So we're going to start like we always do. I'll make a huge line so I don't run out of space. Line times line. Once again, what the problem gives us, here's what it's giving us, is going to go on the top left line. 4.5 moles of aluminum. So we got 4.5 moles of Al aluminum. Since aluminum's on the top left, we know aluminum is going to go bottom right because it's going to cross out aluminum, cross out aluminum. So we're going to get rid of aluminum. We're going to turn it into what we want. We want H2. So I know H2 goes on top. All right, but remember, you got to remember the numbers that go with it. What goes with aluminum? Right here, 2. So I made this line way too big, but who cares? Better to have too much space than not enough. So the 2 goes with aluminum on the bottom because if it's top right, it's going to go bottom left, or top left, it's going to go bottom right. And what goes with the H2 right there? 3. So I put the 3 next to the H2. Now I got the ratio. This is the mole ratio. So it's turning 4.5 moles of aluminum, and it's going to tell us how many moles of H2 that would be. So equals, so it's top times, this one I'm going to have to use a calculator because we got 4.5 over here. It's not a simple number. So it's 4.5 times 3 divided by 2. 4.5 times 3 divided by 2 equals, according to my calculator, if you do that, 4.5 times 3 divided by 2, you're going to get 6.75 moles of hydrogen gas, or H2. All right, so you're going to have like probably around two or three questions like this on your test. And I'm going to post this on Google Classroom so you can get more practice. I'm going to do one of the hard ones. All right, so I did number 3 for a while, but then I saw it gave me 28 grams of N2, and 1 mole is 28 grams, so I thought that was too easy. So I'm like, let's do number 4. So I got almost all the way through it, and I saw that the ratio is 1 mole of sulfur, 1 mole of O2 to 1 mole of sulfur dioxide. 1, 1, 1. Too easy. So now I came down here. It's my third one doing this. All right, so this is not all the same, doesn't have the same mole ratio. So this is propane C3H8. 1 mole, remember there's no 1 here, but that means since there's no number, it means 1 mole of propane is going to react with 5 moles of oxygen. It's a combustion reaction, burning, to create 3 moles of CO2 and 4 moles of H2O water. All right, so we're going to do this in 3 steps. Step 1, convert grams to moles because it's giving us grams, 22 grams of propane, C3H8. Step 2, use the mole ratio. And then step 3, since it's asking how many grams, not how many moles, we got to go step 3, we got to convert moles back to grams. All right, let me grab my little pen here and let's go ahead and do it. If my thing will move. And there it is. All right, so into step number 1, boom. This is what it gives us, and we're going to fire that top left. So 22, I'm going to drop the 0.0 to make it smaller. We get 22 grams of C3H8. All right, so we got grams of C3H8. Since we got grams on the top left and we're looking for moles, we want to convert grams to moles. We know grams is going to go bottom right, and we know 1 mole is going to go on the top. And how much does 1 mole weigh of propane? 44.1 gram. Look at that, they almost weigh the same, CO2 and propane. All right, so 1 mole of C3H8 is, I don't know if I'll be able to fit it all, 44.1 grams of C3H8. All right, so this right here, 22 times 1 divided by 44. It's going to end up being 22 divided by 44. That's going to turn into 0.5. So we basically have a half a mole of propane here. But we're not done. All we did was we found out how many moles of propane we got here. But we're going to keep on going. Now we're going to find out, well, how many moles of CO2? So we have 0.5 moles of propane, even though if you don't do this, if you don't realize it's 0.5, it doesn't matter. We're going to do the mole ratio here, and doing this right here is going to give us how many moles of CO2 we're going to get. All right, so since we already have the moles of propane, C3H8, it's going to go on the bottom. C3H8. And what we want, CO2, is going to go on the top. CO2. But what's most important is the number in front. Now remember, there's no number here. That means it's 1 mole of propane reacts with 5 moles of oxygen. So we're going to put a number 1 here because 1 mole, this is the ratio, 1 mole. How many for CO2? Oh, I see a 3 in front of it. So it's going to, 1 mole of propane is going to make 3 moles of carbon dioxide, CO2. So I put the 3. Boom. Now, once we do all this, it's going to convert the number of moles of propane, CH3, into moles of CO2. But we don't want moles of CO2. We want grams of CO2. So we got to go from moles back to grams. So now we don't want moles. So 1 mole is going to go on the bottom. It's always 1 mole. And what does 1 mole of CO2 weigh? It's 44.01 grams. 1 mole of CO2 is 44.01 grams. All right, so now we got it all set up. Now all we need is a calculator. 22 times 1 is 22. Times 3 is 66. Times 44.01 is, I don't know. So now we just need a calculator. Let me go ahead and get it out. So 22 times 1 is 22. Let me make sure. 22 times 3 is 66, like I thought, times 44.01. 44.01. I screwed up. Try it again. 66 times 44.01 equals. All right, so on the top, we got 2,904.6. 2,904.6 divided by, so we still have to divide it by all this stuff. 44 times 1 times 1. That's pretty easy. I can do that in my head. 44 times 1, 44.1 times 1 is 44.1. So it's 44.1. So we got 44.1 on the bottom. So what is this divided by this? Don't know in my head. I got to use a calculator. 2,904.6. Notice I'm not rounding off. I'm going to keep it precise. Divided by 44.1 equals 65.86 equals, we're going to get 65.86 grams of CO2. Now, for those of you guys, you can see for extra credit, you can determine what's called the percent yield. And the formula for percent yield, this will be extra credit on your test, but since we're here, I might as well do it. So you got what's called the actual yield right here. I just totally made up this number, but it'd probably be pretty accurate. So the actual yield is what you measure in a lab. Say you do an experiment and we measure out, we we find that we got in our reaction, we got 62.1 grams of CO2. Maybe we put it in a balloon or something, then we weighed it. So to get the percent yield, what you do is you do the actual yield, which is 62, and this is very easy, 0.1, divided by the theoretical yield, which we just calculated. Theoretically, with this reaction, with that much propane, we should have got 65.86 grams, but we only got 62.1. Now, if I can get my cursor, there we go, back over here. So it's actual yield divided by the theoretical, which is 65.86 grams times the number 100. And that's going to give us the percent yield. And just doing it, it's usually the high 80s. So 62.1 divided by 65.86, 65.86 equals, it's 94. So times 100 is going to be 94.3%. So we expected to get 65.86 grams. We got 62.1. So our yield, we got 94.3% of what we expected. Remember, this is totally extra credit. And while I'm on extra credit, I'm going to post this on Google Classroom. This is another extra credit, finding the limiting reactant. This is 100% extra credit. So if you'd like to try this, I know there's a video on Google Classroom that shows me going over, I believe, this one. And if you need more help, ask me coming to class during lunch, and I can show you how to get more extra credit doing these. All right, so come to lunch if you need help, and I will see you for our test, most likely this week on Friday.